That's when I should have used the step over. Huh? Let me do that this time. Let me just forget where I was. Okay, reload. Try to do this efficiently now. So I'm going to do step over. No. Step out of the current routine. Step through current. Step over. I'm trying to figure out where the jump was that brought me into this section. Oh, that does not do what I wanted to do. I needed to be doing step over, not step out. Alright. That got me out of the section entirely. Okay. So we want to just step over. We're not trying to go into routines. So we want to execute them and go back into after it's run. Jump statements provide no means of doing that. I'm actually not interested in any of this until the return. Until we get into a jump. Should I do plan B? Plan B is to search. No, I didn't want to do that. Can I do this? Control F or something? Tile viewer. Properties. Wait. PC is 85D8XC1. I need to find an efficient way to figure out what piece of code jumped to a current location. Alright. I know the range is between 85D85E and 85D86C. Some piece of code contains a statement that jumped to one of these statements. And it's probably 85D85E. 85D85. So I'm looking for D85E. Hang on. D85E. I see it right up there. So that would skip past here. 0109. So something that landed on these addresses. Let me just reload and see if that instruction's going to run. Yeah, where did we go wrong? D8541. D8541 must be where it came from. Let's run again. Maybe not. We're at D8546. 85D856. Let me mark arcs, and there shouldn't even be a write to it, since it's instruction memory, right? Okay. D80, let's run again. We end up in this procedure a lot. So what if I put DCO2 in here? Step, step, step. It goes back to DCO. 850109. Zero 1001 DC 00. So what if I put 2 in there? And I set the accumulator back to 2. LDA 13BF. And if I go to 13BF, I'm going to go to 13B, and F is this field right here. I'm going to put a 2 in it. Okay. So that's just going to load it. It says DC02 still. So I changed 109 and 13BF at 85D85.6. I'm now going to see if this has an effect. Alright. It did. Hey, I'm back in the same level. It didn't start me back off at level 1. Alright, so I have a successful injection. Well, a successful tampering of the thing. Well, that's interesting. But bombs don't interact with turtle shells. And apparently I can't stop them from going off. I thought kicking a bomb horizontally reset the counter. It doesn't seem to here. You may learn it if I, in a slide, and I catch the falling man, I may carry him in the slide. Well, it went back to 85D85.6. Something about the message box runs that same bit of code again. That's interesting. Not that it caused any problems, as long as I... Okay. So all I gathered from that is I reload the game. Now I'm in this... I'm not ready to do it yet. I have to pit run again. But I know where to inject code now, I think. I made a mistake and didn't do the thing that I wanted to do. Hit run. Okay. So it says DC01. I'm changing the accumulator to DC02. And I'm at address 85D85.6. I'm making a comment here. Inject here. Set A is... Let me try DC03, actually. That'll be like a proof type situation. Alright, DC03. Now I go to 13BF. I'm gonna put a 3 in that byte position. Then I'm going to go back up to 109. 109. I'm going to ignore that for now. I'm at a different point in the code. It may have a different effect. I'm changed only 13BF, and I changed it okay. Hey, that worked. Now let me reload. I'm going back to 13BF. It looks like 13BF may be enough to tweak it, as long as I change it at the right instruction. Alright. 13 BF. Has 00 in it right now. Okay, I'm entering the game. 85D856. I'm changing it to a 4. Now let's see. Do I need to change the accumulator as well? Does that matter? Let's run. Let's just see. Let's just see. So you have a star, but it doesn't really help you. You still die. I don't know that it matters. I just needed to change 13BF at the right place to end up in... Alright. So I'm changing it to a 4. I'm changing it to a 5 now. I'll change the accumulator too. Hit run. I'm going to unbreakpoint these. Actually, I'll just turn those breakpoints off. Just leave 856 on. Yeah, that one I'm leaving on. Okay. Run. Now we get to do the fun part, which is to write a bit of assembly. I need a free piece of free memory. So, first off, I need a terminal window. I should have one of those. Well, temp3.asm. So I value was DC00 and let me see. I'm trying to inject at 85D856, so I'm writing, let's see, maybe I should just start with a blank file. I just need some sample piece to org auto clean JSON main. Terra, that is what I need. That is the bit I need as a sample bit. ASM. Okay, I'm gonna paste that in. Origin 85D856. I don't know if that's the right way to phrase this. 85 D856. Because ultimately that might not correspond to the ROM address. Let me just see something. So I'm auto clean JSL main. I don't want to know out. I don't want to know up anything. I do need to do something about that D85E. So I branch after all this is said and done. I'll probably have to replace both of these instructions. So auto clean JSL main. Branch E. I don't know that I can inject right there, but we'll see. All I want to do is have the address in the accumulator LDA 03 STA 13BF. RTL. Okay, and the problem is this auto clean JSL is going to overwrite that B and E. Let me just see something. Code JSL. I need to look at the actual opcode for it. I think this is going to be a 3-byte instruction. I need to look at the properties, miscellaneous. Can I inject here? That is the question. Branch.e. D85E. This may not be the optimal debugger to be looking at this in. So I could put LDA 109 here, right after the thing. Okay. So this instruction will be replaced with JSL main 85D85 6 7. This is at 8580, which means that this is a 2-byte instruction. And JSL is a 3-byte instruction. So when I put JSL main here, it's going to be wiping out this and the LDA. So what I need to put in after this six, seven, eight. 85, 8 to B. Okay. The problem is this is a branch, so it may be branching to 85E, or it may not be. If it's branching to 85B, then this part is irrelevant. So I need to do... Unfortunately, I don't have that luxury of testing this condition, so I need to say branch not E, 85B, X. And if there's no branch, I need to load that. O109. So that completely replaces these two instructions. They'll be handled in the new subroutine. So I'm good there, right? I just need to figure out what I need to knock out over here. So JSL, it's 3-byte instruction. I'll be knopping out. That overwrites the branch 6-7, and it overwrites the first byte of this LDA. So I also need to knock out the second byte of the LDA. 01, 09. That's a 3-byte instruction, is it not? LDA starts at 858 and ends at 85B. So 858 is the first byte, 859 is the second byte, 85A is the third byte, 85B is the fourth byte. So that is 3. That's actually a 4-byte instruction. Really? No. 01. That's a 2-byte argument. Then there's a third one. I need the opcode detail for that. Isn't there a way I can just edit in place? That was a different debugger I was using. I had that feature. That's why this one doesn't even show the raw output. Okay. JML. No. I'm doing JSL. I need this. I need the full opcode reference. Let me see what I can do about that. Give it a minute. I know I have a link for that. It's been so long since I read it. 6502 opcodes. .org. Don't tell me it's really that simple. I just... Give me a web browser. Alright. .org. No. Not forum, just 6502.org. This site cannot... Timed out? Hang on. Don't tell me the website's down. That pasted the assembly code I was typing. .6502. It's not a secure website. That's the problem. That is the problem. Alright. Tutorials. 65C816 opcodes.html. 65C816. 816. What did it do? Send me to another virtual desktop? Oh boy, what key did I press that time? I don't like these shortcut keys that activate when you're not trying to activate shortcut keys. .65C816 opcodes.html. .65C816 opcodes.html. Did I type it right that time? It looks like I did. Now I just need text big enough to for me to actually read some of it. Alright. So I'm trying to write an instruction, and I'm looking up the length of that instruction, and so I need to, let me first look up B&E. B&E. Branch not equal. Mode related 8. Label branch label 2, 3 cycles. Unconditionally branches, that's not the one we're used. We have the B&E. We have B&E. Let me find B&E. Matches if the Z flag is 0. The names BEQ and BE come from the fact that these two instructions follow a compare CPX or CPY. Thus, will branch if the register and the data were equal or not equal, B&E. We're testing for non-equal. And so the condition is if the Z flag is 0, then yes. But which variant of the instruction is it? It is here, it is length 2, so it's 2 bytes. So this is a 2-byte instruction, and we're writing JSL to it. JSL in this format, JSL to an address is a 4-byte instruction. So the first 2 bytes will overwrite this instruction. The 3rd byte will overwrite the opcode of this instruction. And this format of LDA I'm looking it up. It's LDA with a $sign and 2 bytes. So that is like this. And that's a 3-byte instruction. Okay, so it's a 3-byte instruction. So 2 bytes of LDA have been... So we have written 4 bytes to over B and A. So those first 2 bytes overwrite this instruction, and that 3rd byte overflows into this one, and this one is, this LDA is a 3-byte instruction, so there are 2 bytes left in it. And that means I need to knock out both bytes. That will knock out the LDA. So this whole thing is being replaced to jump to this code in free memory, hopefully. And the first thing we're doing is we're loading onto the accumulator. Not pushing. Then we're storing so we put the level number we want. I'm going to say A number is 03. That represents the level number, so I can now use that as a macro. A number. We're loading the A number into the accumulator. Then we're going to override 13BF with it. And 85B comma X, I think I made a mistake there. That's not how that instruction works. First of all, it's D85E, not 85B. Oh, wait. Hold on. Branch not equal D85E. We haven't done anything to the compare at all, so... No, that is not how this works. This is not how this works at all. I don't know why I did it that way. We need to branch not equal X, right? What it is I named my label the same thing as the X register, and I shouldn't. So, what I'm saying is E-test. Let me call it that. You put the dot as the label, but not the mnemonic. Okay. And then, so I'm back here. So if we branched here, then we didn't run this. We would go straight to D85E. So that's why I'm putting this here. If that compare would do that way, then I don't want to touch the accumulator anymore, if possible. So I handle that. then return. That allows me to eliminate the load accumulator. The problem I have is I still have the branch D85E that needs to be fixed. What does the code at D85E do? I think what I'm going to do is I'm going to completely replicate it. So I'm looking at D85E. What I'm gonna do, since I'm hijacking that instruction, I have to recreate the effect that it would have. So I'm branching into eTest. I'm just thinking about this clearly. Branching into eTest skips the 0109. But you know what the problem is? I don't want to do this code twice. So what I need to do is RTL. Then, this code only occurs if the branch would have been executed. So now I can go look at D85E, and I can duplicate this code into here. LDX 010A, LDA 0109. I can't do this one. D872 is a problem. Okay. But what I've taken out is 2 instructions. So what I can do is I can go back up here. And those instructions have run already. So those two can be knocked out. Oh, 109 has already been knocked out, and I have this D8A5. The jump is going to be what? How big is the jump? Jump. It's in this mode. It's an absolute jump. It's 3 length. Jump, it's got 2 bytes on it. So it is a length 3 instruction. So I've knocked out that jump to jump is gone now. And I can knock out the LDX and the LDA. Alright. The LDX. The LDX is like this. No. It's this one. It is 3 length 3. Yeah. So I'm going to comment out what I'm going to just make a little note about what I'm in the assembly comments about what I'm knopping out. So this is the 0109. Knop 3 is the entire instruction for jump D8A5. This one is LDX 010A, and this one is LDY. No. It's not LDY, it's LDA 0109. Okay. So what I need to restore is the branch and the jump. So 3, 6, 9. There are 11 bytes here. This one cannot change. Why can't I change that one? I actually can though. I'm not sure about the alignment requirements here. I'm putting question mark. I want to start here. So, what am I doing? I'm putting in the D8E5, branch not equal D85E. Branch not equal D85E. And I need to check the length of that. I just checked the length not too long ago. Wasn't it 4? Branch not E. It's not a label, it's... I know the raw values. It's length 2 according to this. I'm going to say length is 2. So that consumes 2 of those knop bytes. But I still need one more knop. One more byte. One more knop. And that puts me ready to put in the original jump statement, right? Jump D8A5 and that is 3 bytes. Link is 3. LDX 010. These are 2-byte instructions, right? It's a 3-byte instruction. So LDX and LDY, those were 3-byte instructions. LDX length 3. And I'm just trying to keep track of how many bytes I'm writing. Nop is a 1 byte instruction. Branch not equal. That is a 2 byte instruction, right? Here we go. Always length 2, I think. This NOP is NOP number 2. That means 2 NOPs, so that's length 2. Alright. Now let's see what the layout of the what I'm writing to memory looks like. So auto clean, it's going to be JSL. JSL, that's 1 byte, NN, branch not equal, a 2nd byte, NOP, wait. I didn't do this right. Nop. Branch not equal. Nothing there. Just 1 byte there. Then I have jump. 1, 2, 3. That's actually just 2 bytes. Nop. So I'm writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, 15. If I understand correctly, that's writing 16 bytes. And they'll start at 856. D856. D856. D856 plus 16. Let me switch into radix 16. So I'm running hex OX D866. That gets everything up to D866. That's not good. I'm overwriting too many bytes. So where do I need to pull out? Branch not equal. I need to pull in 2 bytes less. So this shouldn't be a big deal. So I can take out these 2 NOPs. I can NOP 1. And I'll be writing 14 bytes total. I'll end at OXD864, which is right at that branch statement. Let me just see what happens then. Flips apply. flip supply. Patch ROM output. Flip supply storks.bps smw.sfc. Storks, shoot. What did I write? 03? x03.sfc. asr temp3 storks x03. I probably have syntax errors because why wouldn't I? Line 8. Is my NOP a syntax error? I thought you could NOP things. Why is it saying that's a syntax? I put a comment without properly marking it. 18 temp3.asm. Branch not equal. Do we have to do it like this? I don't know. I know I've done branches before. Level depending on event has something like that. Set level. Oh, you know what? The label syntax is wrong. Silly me. It's that. I think that's right. Maybe that's right. Maybe you don't need the dot. Or I didn't put the dot in the label. There we go. SNES 9X config. 9X Storks X03. Huh? Didn't I have a launcher for a script I wrote a long time ago? That I did. Conf. The command line option is -conf. There we go. Okay, let's start the game. Now the question is, does the patch do anything? I wound up in a test level. Well, it did something, just not what I thought. You know what I think I'm doing is I'm loading a memory address instead of I'm loading whatever's at the memory address instead of what's at the direct. I need to load DA with a hash in front for direct load. Okay. Instead of load indirect. Let's see. Let's go flip supply. Let's go back to our original stock file. Put it like that. I'm gonna get the syntax exactly right. I don't know. I definitely did manage to affect the level loading, but there may be some unintended side effects going on. So let me just review this a little bit. D85E. Jump. 3, 4. Not number 2. Branch not equal. There's a chance that there are other jumps in the middle of this procedure. In that case... let me just see, take a look around. Just some main. I don't need to knock out whole instructions. The truth is that's not conflicting with anything. It shouldn't be. Start at 0. Apply ASR SNES. Apply. What would I say if I just... because I know the LDA is supposed to be a byte instruction. What if I just said O2? Just comment out these. Comment those all together for just a moment. Oh, you know what's going on? Okay. I think I have a good idea what's going on now. It was actually the first bit was changing. The first part was also changing. Okay. So what happens if I say DCO2 then? Because it never was. Oh no. That crashes. You can't load DCO2 into the accumulator. Okay. What I can do is store '08 store accumulator. So I'm in a location where I can do some things. So let's say LDA. LDA, DC, STA, 13C0. I don't know. That really shouldn't affect anything. Well, I ended up somewhere else, so it did affect things. Sadly, it's just not what you might think you want. I will put 0, 0. So that's interesting, just messing with this next byte. Did something, but it's not what you want. I may have to go back this later. Because I don't know what values are. So store 13C0. I'm writing 0, 0. Load, and what if I store it also into 109? Okay. Let's try 04. No. Could it be that I've been... Let's try 04. That did change which level's loading, it just didn't quite affect things right. I have the feeling my inject broke something else. And, that's interesting. So I'm somehow not in the right level range. Uh-huh. So I wrote 3 bytes, and that took care of those 2 instructions, but so the LDA is what messed up. So this is just clearing the LDA overrides. So I'm and the very next thing I'm doing is I'm dropping a B and E over the jump. D85E. But didn't I just, in the purpose of my code there to... So the question is, what will I be writing to D85E then? That's why I'm now branching to the wrong place. I'm now branching to the wrong place. Because D85E is where the LDX instruction was. D85E minus D85-6. That's 8. It's 8 bytes in. So I'm gonna count the bytes. This is 3, 4, 5, 6, 7, 8. It's branching right before the jump. But it should be branching right after the jump. So I need to adjust the address on that. Right. I need to add 85E 1, 2, 3 to 86 2. To push the jump after the branch after the target after the jump. Okay. Let's see what we get here. What the heck did I just do? Fixed? No, I broke it. Even worse. Okay, let me just read off. I want to start D8802. Just restore these to what I thought they should be. And I'm not gonna mess with 0109 anymore. There's still something else wrong. I really should mess with 0109, maybe. DX. Illinois. There you go. I think my hijack calculation is wrong. I must have jumped into the middle of an instruction or something. Recheck branch computation. To do. I'll have to go fight with this later, maybe. D863, that's wrong, obviously. That's even worse. Okay, I'm gonna come back later and check over with a different debugger. See how I figure out why the hijack is breaking. I'm probably overwriting more than I expected. I just need to reformulate it. But I know the principle would work if I could get the detailed